Next is a rectangular channel has a bottom width of 4 meters. What is the depth of the channel? So we have here the illustration which is the D is equals to 2D, and this is our depth. So first we have here B is equals to 2D. We use this formula, then substitute the 4 meters, then equals to 2D. We have the depth of 2 meters. Next is a pipe has a velocity of 32.2 feet per second. Determine the flow in cubic feet per second if it has a diameter of 15 inches. So our diameter is 15 inches, then convert it into feet. We have 1.25 feet. Then our radius is 0.0625 feet. Then our area is pi r squared is equals to pi times 0.625 squared is equals to 1.227 feet squared. Then we use the formula of discharge is equals to area times the velocity. We have Q is equals to 1.227 times 32.2. We have the discharge of 39.51 cubic feet per second. A discharge of 1.2 cubic meter per second flows on an open channel with a slope of 0.0062. If n is equals to 0.012, compute the depth of the channel for an optimum discharge for semicircular section. So this is our semicircular section. We have our radius. And our hydraulic radius is equal to d over 4. Then we use the formula of Q is equals to area times 1 over n times the hydraulic radius raised to the power of 2/3 times the slope raised to 1/2. Then substitute the given. We have 1.2 is equals to pi over 4 d squared times d over 4 raised to 2/3, and our slope of 0.0062 raised to 1/2 over 0.012. We get the diameter, we get the depth of 0.82 meters. A rectangular channel 10 meters wide carries 60 meter cube per second when flowing 3 meters deep. What is the specific energy? So we use Q is equals to AB. Our Q is equals to 60 and equals to, our area is 10 times the depth, which is 3, 10 times 3 times the velocity. We have velocity of 2 meter per second. Then we use the specific energy formula, which is specific energy is equals to V squared over 2G plus D. Then substitute the given. We have 2 squared over 2 times 9.81 plus 3. We get the specific energy of 3.20 meters. A rectangular channel having a width of 3 meters has a constant specific energy of 2 Newton meter per meter. Compute the critical depth. So we use the formula of critical depth is equals to 2/3 times the specific energy. Then critical depth is equals to 2/3 times the specific energy of 2 is equals to 1.33 meters. A rectangular channel has a width of 3.6 meters with a roughness coefficient of 0.013. Compute the critical flow at a depth of 1.20 meters. So we use the critical depth is equals to cube root of Q squared over G. And we have critical depth of 1.2 is equals to cube root of Q squared over 9.81. We get the Q is equals to 4.12 meter cube per second per meter. Then we use the formula of flow rate is equals to Q times the velocity. We have Q is equals to 4.2 times the velocity of 3.6, and we get Q is equals to 14.83 cubic meter per second. A rectangular channel 4 meters wide shows a wavy surface at a depth of 2.5 meters. Estimate the rate of discharge. So we have critical depth of 2.5 meters. Then use the formula of critical depth is equal to cube root of q squared over g. Then we get critical depth cube is equal to q squared over g. Then substitute the given. We have 2.5 cube is equal to q squared over 9.81. So we get 12.38 meter cube per second per meter. Then use the flow rate is equal to q times the velocity. We have q is equal to 12.38 times the velocity of 4. We get 49.5 meter cube per second. At a section in the triangular channel, the depth of water is 3 meters and the average velocity is 2.44 meter per second. So calculate the rate of flow. We have the illustration here. Then, first, we have tangent 22.5, which is the angle is half of this, equals to x over 3. We have x is equals to 1.2426. Then our area is equals to 2x. Substitute the x into the area times 3 over 2. We have area of 3.728 meters squared. Then use the formula of Q is equals to AB. We have Q is equals to area of 3.728 times the velocity of 2.44. We have Q is equals to 9.096 meter cube per second. Next is a triangular duct flows partly full. The critical depth is 0.6 meters and roughness coefficient of 0.016. So we have tangent 60 equals to 0.6 over x. So we have x 0.3464 meters. Then b is equals to 1 minus 2x. We have b is equals to 1 minus 2 times the x, which is 0.3464. Our b is equals to 0.3072. So our area is equals to 0.3072 plus 1 times 0.60 over 2. We have area of 0.3922 meter squared. A circular conduit flowing half full carries 14.17 cubic meter per second at 3 meter per second. If roughness coefficient is 0.013, compute the diameter of the conduit. We have Q is equals to area times the velocity. Our flow rate is equals to 14.17 equals 4 times d squared over 4 times 2 times 3. So we have diameter of 3.47 meters. A sewer pipe has a diameter of 800 mm. The n is equals to 0.012 and slope of 0.001. Compute the depth of water for maximum velocity. So our depth of flows is equals to 0.81d. We use this formula. D is equals to 0.81 times the diameter, which is 800. We have D is equals to 648 mm. From the given cross-section of a canal, the channel slope is 0.0010, side slope is 1:1. Compute the total cross-sectional area. So we have the diagram here, and area is equals to 7.438 times 7.438 over 2 plus 17 times 7.438 minus 5 times 5 over 2 plus 1 122.438 plus 120 over 2 times 2.438. So we get the area of 464.80 meters squared. A flow of 3.4 meter cube per second is carried in a rectangular channel 3 meter wide at a depth of 0.46 meters. So the channel is made of smooth concrete. Our roughness coefficient is 0.013. Find the necessary slope. Then we have our base with 3 meters. Our depth is 0.46 meters. So our area is equal to 3 times 0.46 equals 1.38. Our perimeter is 3 plus 2 times 0.46 is equal to 3.92. So our hydraulic radius is equal to area over perimeter. We have 1.38 over 3.92. We have 0.352. So we use this formula, then substitute the given. We have 3.4 is equal to 1.38 times 1 over 0.013 times 0.352 raised to 2/3 times s raised to 1/2. So we get a slope of 0.00413. The next problem is a square concrete conduit having a side of 0.788 meters. Carries water at a rate of 4 meter cube per second using Hazen-Williams formula with C is equals to 120. So compute the hydraulic radius. Our velocity is equals to discharge over area. We have V is equals to 4 over 0.788 squared. We have our velocity of 6.44 meter per second. Our area is equals to 0.788 squared. Our perimeter is 0.788 times 4. So our hydraulic radius is equals to area over perimeter. We have R is equals to 0.788 squared over 4 times 0.788. So we get the hydraulic radius of 0.197. Next is a stream having a width of 4 meters, carries flow rate of 14.88 meter cube per second with a velocity of 5.8 meter per second at an initial point. Compute the Froude number at this point. So we have Q is equals to 14.88 over 4. We have our Q is equals to 3.72 meter cube per second. So we have QA1 V1. We have Q is equals to 3.72 equals 1 times D1 times 5.18. We have our RD1 is equals to 0.718 meters. So our Froude to get the Froude number, we have F is equals to V over square root of GD. So our F is equals to 5.8 over square root of 9.81 times 0.718. We get 1.95. So for problem 41, we have for a flow rate of 9 meter cube per second and a rectangular channel shown having a width of 3 meters where a hydraulic jump occurs. Compute the depth or the D1. We have our Q is equals to 9 meter cube per second. We have this formula, then substitute the given 3 times 3. VA is equals to 9. We have our value of VA is equals to 1 meter per second. Next is the Q is equals to 9 over 3. We have 3 meters raised to 3 per second. Then use this formula, which is V cubed over 2G plus 3 is equals to V squared over 2G plus D1. So you have V1 D1 times 1 is equals to 3. V1 is equals to 3 over D1. Then 1 cube over 2G plus 3 is equals to 3 over D1 squared times 1 over 2G plus D1. The value of G is 9.8 meter per second. We have 30 we have 3.05 is equals to 9 over d1 squared times 2 times 9.81 plus d. So we have the value of d is equals to 0.399. A nozzle of 50 mm diameter delivers a stream of water at a velocity of 65 meter per second, perpendicular to a fixed plate. Calculate the force on the plate. So we have F is equals to density times the area times the velocity squared. We have F is equals to 1000 times the pi over 4 times 0.05 squared times 65 squared. So we have force on the plate is equals to 8,295.77 Newton. Next problem is a jet of water 75 mm diameter and moving to the right impinges on a flat plate had normal to its axis. If the velocity of the jet is 25 meter per second. So we have the illustration. Then we use the formula of force is equals to density times the area times the velocity squared. So we have F is equals to 1000 times the area of pi over 4 times 0.075 squared times 25 squared. We have the force is equals to 2,761 Newton. Next is a horizontal 100 mm diameter jet of water with M is equals to 300 kg per second strikes a vertical plate. Determine the force needed to hold the plate stationary. We have force is equals to density times area times V. We have M is equals to density times area times the velocity. So our M is equals to 300 is equals to 1000 times the area of pi over 4 times 0.10 squared times V. So we get the value of velocity. We have 38.20 meters per second. A 50 mm diameter horizontal jet of water strikes a flat plate as shown. So determine the jet velocity if an 80 Newton horizontal force is required to permit the plate to move at a constant speed of 2 meters per second to the right. So we have F is equals to density times the area times V1 minus V2 squared. So our force is 80. Then our density is 1000 times the area, which is pi over 4 times 0.075 squared times V1 minus 2 squared. So we have our V1 minus 2 squared is equals to 40.744. We have our V2 minus 2 is equals to 6.38. So our V1 is equals to 8.38 meter per second. A vertical jet of water through a nozzle supports a load of 150 Newton. The velocity and diameter of the jet at the nozzle tip are 15.46 meter per second and 30 centimeters. Find the distance of load from the nozzle tip in meters. So we have Q is equals to area times the velocity. Q is equals to, our area is pi over 4d squared, which is 0.03 squared. Our velocity is 17.46. Then we get the value of Q is equals to 0.0123 meter cubed per second. Then use the formula of F is equals to Q times the weight over the gravity times the velocity. So we have 150 is equals to 0.0123 times 9,810 times the velocity over 9.81. So we get the velocity is equals to 12.154 meter per second. Then our velocity squared is equals to the initial velocity squared minus 2gh, then 12.154 squared is equals to 17.46 squared minus 2 times 9.81 times h. So we got the value of H is equals to 8 meters. Determine the drag on a paddle with an area of 0.06 square meter moving horizontally at 0.8 meter per second. So our CD is equals to 0.45. We use the formula of FD is equals to CD times the density times area times the velocity squared over 2. Then substitute the given. We have FD is equals to 0.5 times 1000 times 0.06 times 0.8 squared over 2 to get the value of FD is equals to 8.64 Newton. What is the drag force of a 12 mm diameter sphere that drops at a rate of 8 cm per second in oil having a specific gravity of 0.85? Drag coefficient is 5.3. So we have FD is equals to CD over the times the density times area times velocity squared over 2. So we have FD is equals to 5.3 times 0.85 times the density is 1000 times the area of pi over 4 times 0.012 squared times 0.08. So we have FD is equals to 1.63 times 10 raised to negative 3 N. A turbine is to operate at 300 revolutions per minute under a net head of 400 meter. So CV is equals to 0.98. If a single 15 centimeter water jet is used, what is the discharge or the Q? We have the formula here. V is equals to CV, or V is equals to square root of 2GH. So we have velocity is equals to 86.82 meter per second. Discharge is equals to AB. We have Q is equals to pi over 4 times 0.15 squared times 86.82. So we have a discharge is equals to 1.53 cubic meter per second. Lastly, is a turbine is to operate at 30 revolutions per minute under a net head of 400 meters. So our CV is equals to 0.93. If a single single 15 centimeter water jet is used, find the required pitch diameter of the wheel, assuming peripheral velocity is equals to 0.45 and an N is equals to 0.85. So U is equals to diameter times square root of 2GH. U is equals to 0.45 square root of 2 times 9.81 times 400. So our U is equals to 39.87 meter per second. Then U is equals to pi d n over 60. So our U is equals to 39.87 equals pi d times 300 over 60. So we have our D is equals to 2.54 meters.